And now I'm not going to start this. I'm not going to jump here. So again, this part is not in exam. So the idea I talked about Friday is that how the heck people solve this kind of problem? How do people know this is the answer? How people know this? There's a way you can solve that. It's called Gospel algorithm. It's invented by the first ever hacker in this world. He is still alive, okay? And you think about a method. And the math behind is probably studied by Gauss. The 1 plus 2 plus 3 plus 100 is that person, okay? And the idea is called hypergeometric function. I'm not going to test this in this module. I just let you know, due to some reason, for example, you have to count something and you need to solve this kind of problem, what should you do? Again, not exam. What is hypergeometric function? First, we go back to the rising and falling polynomial. So I just talked about the rising and falling polynomial. That means you stop n time. You stop n time. That's it. Now, what is hypergeometric function? Hypergeometric function is you have a bunch of factorial, divide each other, multiply a z power k divided by k factorial. This is a name. Do not be scared. My point is, this a1, a2, an up b1, b2, bn to the n, what are they? They are just some number. And a shocking fact is that all mathematical functions are special case of hypergeometric function. I'm saying all. So for example, e to the power z, you imagine this kind of a1, a2, a3, b1, b2, p3 is what? You think of this as E is a grid. It's a grid. And all these a1, a2, a3, a4, a5 are what? Home address. It's like what? This is a map. Think of this is the math god, mathematics god, okay? He's playing a computer game. And then he viewed this in a screen. These are an address. Each coordinate is a houses. Inside live a function. So for example, this one x 1, 2, 3, 4. So this is 4. And then this y coordinate is 0, 1, 2, 3, 3. So this address is 4, 3. Inside this address, there is a function lived inside. And now I'm telling you, all functions live in this mathematical world. And you can write all functions in this form. And here are examples. E to the power z is coordinate 1, 1. That means in the coordinate location 1, 1 is inside this house, there's a function, it's Ez. And then in coordinate 1, 1, 1, 2a and 1b live inside this function. And then for this any a, this one is funny, for all the a, this guy is an x, right? I don't care where, I live the whole street. This function live on the whole street here is this function. That means all functions live inside this coordinate. Now, once this is you got the idea, is what? It's just some funny factorial multiply each other times the power of z. Once you get to this, then how do you solve this kind of thing? This is how you solve this kind of thing. Again, this is not in exam. I just tell you, if you somehow need to solve this kind of thing, how should you proceed? So what is this? N choose k. So n factorial, k factorial, n minus k factorial. There's a square, right? So there is a square. Okay, what is this? 2k choose k, 2k factorial, and then k factorial, right? So you have k factorial square. So this equal sign, easy, right? Then what's next? This 2 go to here, you get this one. This 2k is this 2k, nothing changed. This k square is combined with the k square here, become k4. And then n minus k factorial power square, you have this. Okay, now we are at this step. Then what I'm going to do, these have 4 copies of k factorial. I split them, 1 is there, and 3 is here. So recall that 1 rise to k, ceiling factorial is k factorial. So 2 of them, I write it as 1 like this. I did not change anything. And this k stay here. Okay? And now this 2k, I divide by this k factorial, stay here. Okay? Nothing changed, right? So I just change this 2 to a 1, 1. Then now I have a red term. What's the red term? Red term is n fact square divided by n minus k fact square. So it's what? N times n minus 1 times another time up to k plus 1 square, right? This bracket square means I repeat this bracket 2 times. Right? Then what? How many terms are there? There are k terms here. I insert each guy a negative 1. So I put a negative 1 here, I put a negative 1 here, I put a negative 1 here. I have 2 pairs of them, so it's positive. So now I can have this. And then what is this thing? this is exactly this thing. So the red term becomes this thing. Now, what about this part? This part, this is new. This is called double factorial. Double factorial means every time when you go down 2 units. So 2k factorial is go down 2 until 2. That means what? That means I have this, and then what is this? This is, I take out all the 2. These are all even number. I have this term. I should have a 2 to the power k because I kept them. But then I multiply another 2k and divide by 2k. These 2 give me the 2k. And this one, I distribute it into each term. So now I have this funny product. This product is a rising power of half. And this becomes 4k. So now I get this one to here and to here. And then what? This thing is this 4k. This k factorial is this k factorial. This proving is this proving, nothing changed. This term is just this term, nothing changed. And this is exactly a hypergeometric function with negative n half 114. That means what? That means suppose you have a binomial sum. How do you solve this problem? You find a way to write it down as a hypergeometric sequence, and then you just keep simplifying a bunch of crazy factorial. Then you can solve whatever sum you see in the binomial world. And this is true for what? For all functions. All functions. So that means what? This trick is extremely powerful, and I strongly recommend those who want to study PhD, study this. It will be very useful. And for those who don't care, I don't care. No need to care.